what is the greatest integer k for which n upon 18k is an integer? This is an interesting question. I'll actually give you all 2 minutes to think over it. Yeah.
Sir, I have a question.
Right.
Are we allowed to carry scientific calculators while writing GRE exam?
No, you're only allowed to carry the. So you'll only be given the on-screen calculator. You are not necessarily like you're not allowed to carry anything. You'll only be given a scientific calculator.
Okay, we'll be given a scientific calculator.
Yeah.
My brother told when he wrote the exam, he was given the calculator which is in the computer.
Yeah. So you wouldn't be given the scientific calculator. You'll be given the on-screen calculator. Did I say scientific calculator by any chance?
Okay, I heard it now.
Oh, sorry. I might have missaid it. Like you will only have the on-screen calculator. You will not get a calculator. You'll only have a calculator on the screen, which is what you will allow to use. So that is it. This is a very interesting piece of question. Please attempt this even if you have not attempted this earlier. And people who have still like make sure that whatever answer you're choosing is correct. Okay, so yeah, Nikhilesh, would you like to explain?
Yes, sir. So I took the prime factorization for 18, that is 2 into 3 square. So I thought, so if it, the factors are also divisible by n. So I thought the greatest factor would be 3.
Greatest factor. Oh, n has so n has a product of 1, 2, 3 up till 30. Okay. Now factors for like if we write out the factors, there is 18. For 18, there is 1 and 18. Then there is 2 and 9. Then there is 3 and 6. And then there is what? What else? I think that is it. Yeah. So 18 is anyway going to be there. 2 and 9 will obviously be there, which will make up 18, and 3 and 6 will also make up 18. Okay. Apart from that, if let's say you have 27, right? You can take out 2, 3 here, and let's take 4. You can also take a 2 from here to make 18. then 1 3 will be left here, and 1 2 will be left. Then the next number that you can pick is 8, right? So 8 from 8, okay, no, not 8. I mean 8 obviously can be picked, but also you need another 3. So let's take 12. From 12 you can pick 1 3, and now 1 3 1 2 a single two twos are left. So this way also 18 can be formed, right? So how we'll do this? How we'll determine that how many times will we get factors in this manner? Okay. So first thing first, what we'll do is we need 2 ones and we need 3 twice. Okay. So what we'll do, we'll write down all the possible values where 3 and 2 come. Okay. So now let's see how do we do that. Okay. So first of all, you divide 30 by 2. Then you divide 30 by 4. You keep on dividing 30 by the increasing power of 2. Okay. You keep on dividing 30 by the increasing power of 2. So this will give us 1. This will give us, this will give us 15, not 1. This will give us 1. Write out all the questions basically. This will give us 7. This will give us 3, and this will give us 1.
So why are we doing this?
Right, what?
Why are we dividing 30 by increasing powers?
I am not able to understand what.
Why are we dividing 30 by increasing powers of 2? I didn't understand that.
Okay. So we are basically finding out how many numbers from 1 to 30 have a factor of 2. Okay, but at least once. How do we do that? We'll write out basically all the numbers which have the factor of 2, 1 and only 1 time. Okay, so there is 2, which is 2 into 1. Then there is 6, which is 2 into 3. 8, 10, 10, which is 2 into 5. And then there is 12, no, 14, which is 2 into 7. Then there is 18, which is 2 into 9. Then there is 22, which is 2 into 11. Then there is 26, which is 2 into 13. And then there is 30, which is 2 into 3 into 5. Does this make sense?
Yes.
1, 2, 3, 4, 5, 6, 7, 8. 8. So we have 8 twos basically here. Now we'll write down all the numbers which have the factor of 2 times, exactly 2 times. Okay, not more, not less. So we have 4, which is 2 times 2. Then we have 8 will not be there. Then 12, which has 2 into 2 into 3. And then we have 16 will be number 20, which has 2 into 2 into 5. Then 20, 28, which is 2 into 7. Now there are 4 numbers which have the factor of 2 twice. So basically here we got 16 twos. Oh, sorry. Not the here we got 8 twos. Here we got 4 into 2 twos factor, right? Like 1, 2, 3, 4, 5, 6, 7, 8. So here we got 8. Okay. Then we'll write all the numbers which have the factor of which have at least 3 factors of 2. Exactly 3 factors of 2. So then whoever is unmuted, can you please mute yourself? Thank you. Then there is 8, which is 2 into 2 into 2. Then 16 will not be put because it has 4 twos. then 24, which has 2 into 2 into 2. Now there are two numbers which have the factor of 2 3 times, which are like only two numbers. So 2 into 3, which becomes 6. So 8 plus 8 plus 6. Now we'll write all the possible numbers which have the factor of 2 4 times. So that comes as 16. So 2 into 2 into 2 into 2, which is 1 basically, or like 4 2s. So we'll add 4 here as well. This becomes 10 plus 16, 26. Does this make sense? Vishal, was it you who asked the question?
Sir, I didn't understand this process.
Okay. See, from 1 to 30, there are new, like we have to first of all find out the product and find out how many times can we divide this product by 80. Okay, how many times can we divide? So we first found out like the factors of 18, which was 2 into 3 to the power 2. Now there is obviously 1 into 18, then there is 2 into 9, then there is 3 into 6. These are three combinations which would anyway be present. Why? Because these are the factors which make up 80. Now, apart from these, there will be certain numbers which will also, like, which will combine together, will also divide, which when combined together will make up 18 and will divide this. Okay. So what we can do, we need 1 2 and 2 3s. So if we so this is already taken, this one was already taken, and 3 we have still not talked about. Then this one is already taken. Okay, now 18 and there 3 6 3 is not talked about right now. Now, apart from these, which numbers will, when taken together, divide the product? Okay, to find that out, what we are doing is we are basically counting the number of numbers which have 2 as factor. Does that make sense? Who was it that asked, like, does this part make sense? We are counting the number of numbers which have 2 as factor.
Yes, sir.
Okay. Now, what are we basically doing is we are actually calculating the number of time 2 appears as a factor in this whole product. Okay, which is n of equals to 30 factorial. Does that make sense till now? We are basically counting. So we have 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 and 26. So basically n is equals to 30 factorial. What we can write it as is basically n equals to 2 to the power 26 into some number p. Like, it can be the combination of all these prime numbers which comes into p. Does that make sense? Who was it, Adad? I'm so sorry, I forgot the name.
Yes, sir.
Make sense?
Yes, sir.
Similarly, we'll find the, now instead of doing this whole process, what we basically do is we divide 30 by 2. This will give us the number of numbers which will, I mean, this will count the numbers which will be divisible by 2. Similarly, 30 by 4 will count all the numbers which can be divisible by 4. Similarly, then there is 30 by 8 and then 30 by 60. Okay, so there are 15 numbers which are divisible by 2. There are 7 complete numbers, right? Because if you divide 4 by 30 by 4, you get 7 and 28. Okay, now this here, since this is remaining, this will be counted here basically. Does that make sense? Now for 7, there are seven numbers which have a factor of 4. Similarly, there will be 3 numbers which will have a factor of 8, and there will be only one particular number which will be completely divisible by 16. Does this make sense till now? Anyone who has not understood this? So this gives us 15 plus 10, 25 and 26. Pratisha, you asked the question earlier, does this make sense till here? Instead of doing
Yes,
this
sir.
whole process, the method is you basically keep on dividing the number. Sorry?
I understood, sir.
Right. Now, similarly, there is a process for 3 as well, right? You can just divide 30 by 3, then 30 by 9, and then 30 by 27. So here it will be 10, here it will be 3, and here it will be 1, which will give us 14. Okay. So basically, n, which is 30 factorial, can be written as 2 to the power 26 into 3 to the power 14. And then there will be some other number which will be the product of all prime factors. All the prime factors which are still left here. Okay. Now, we have to divide this number. We have to divide this particular number by 18. Now 18 is 2 into 3, 3 to the power 2, right? So we have to take numbers in this particular format where it is in, we have to arrange this particular thing in this particular format. So we can completely divide this by 18. So 2 to the power 7 into 3 to the power 14 into 2 to the power 19. We have basically separated this into 2 different parts, 19 and 7, using the rule of exponents, and then multiplied by x upon 2 into 3 to the power 2. Now this can be written as 2 into 3 to the power 2 raised to the power 7. Right. Now this cannot be used. Why? Because there is no other factor of 3 to accompany these number of 2's. So this divided by this will give us x to the power 7, or basically 7 times. You can divide n factorial or 30 factorial by 18 7 times. The value of k will be 7. Does anyone have a problem now? Okay, so next question here. This is an interesting question as well. Please make sure that you do this within 2 minutes. This is a very nice question. Okay, now, anyone who's still in this particular question? Okay. Now it says that a cyclist travels the length of a bike that is 225 miles long, rounded to the nearest mile. Now it says that the distance has been rounded off to 225 miles. Now the values which, like, to the nearest mile, right? The values which can be rounded off to 225 miles are 224.5, and the biggest value can be 225.4, right? Or it can also be 224 or 225.449. This particular value can also be rounded down to 225. So instead of doing it like this, what we can say, let's the distance be t and let the time be t. So the distance will be greater or equal to 224.5. Okay, and it will be less than 225.5. Okay, now here, instead of taking as 225.4, why I have written 225.5? Because even the distance as 225.444, this particular distance will also be considered as 225. It will be rounded down to 225. Similarly, when it says for time, so 4.5 hours and anything greater than that will be rounded off to 5. And similarly, anything less than 5.5, even if it is 5 hours, 29 seconds and 29 minutes. 29 minutes and 59 seconds. Even then, this time will be rounded down to 5 hours. So which is less than 5.5. So therefore, this is the range which will be there. Now, if we are to find his average speed, the range of his average speed, then what we have to do is, first of all, we have to find the slowest speed possible. Now, the slowest speed possible is minimum distance covered upon maximum time. Okay, minimum distance covered over maximum time taken to cover that distance. So this is the minimum possible distance, which is 224.5, and the maximum possible time is 5.5. Okay, what we can do is we can basically just divide this. So 224.5 divided by 5.5 gives us somewhere around 40.8. Okay, it gives us approximately 40.8. Now, if the slowest speed possible is this, then what happens is this goes out of the picture. No, sorry, not this one. This goes out of the picture, and then this one also goes out of the picture. Why? Because if the speed is less than 41, then these two cannot be the smallest, the lowest speed. So these three are the only ones which will remain. Now, since he has not covered, the cyclist has not covered any distance below this, then this particular speed will also not apply. Why? Because 38 is an answer which cannot be possible. Now, the fastest speed possible comes from maximum distance covered over minimum time taken. Okay, so maximum distance is this, minimum time is this. So 225.5 over 4.5. Okay, so 225.5 over 4.5 gives us 50.1, somewhere around 50.1. Now the thing is, it is over 50, so this one, as I said earlier, will not apply, and this one will also not apply. The reason being, since even if it is even if it is 0.1 mile per hour over 50. Okay, even 0.1 mile per hour over 50, the maximum range cannot be 50. The maximum value cannot be 50, it has to be more than 50. So the answer becomes 40 miles per hour and 51 mile per hour. Anyone who has a question here, has a problem here, is not able to understand, wants to ask again, anything? Now, we'll get to the next question. I think I've already given, I'll tell the answers for this. This one is 1 kg. This one is
One only.
sorry,
Option A.
option
A.
A, one only. Why?
Because there's no option saying 1 and 3.
Y can be 0 also, no? If m equals to 0, y equals to minus 0 square, which is basically 0, and 0 is neither positive nor negative. So y is not negative. M is negative, then y is negative. That is the only one true. Right? Makes sense?
Yes.
Sir, a doubt. If m is negative, then so
Then
can you just put any value and explain?
m is negative. Anybody tell me any value?
Yeah, -2.
Okay, so this becomes y equals to minus 2 square. This becomes minus 4
Okay,
y,
got it.
right? So when m is negative, y is negative, this is the only statement that holds true. Okay. Now, if n is a positive integer and n square is divisible by 72, then the largest positive integer that must divide n is what?
Sir, is
Answer
it
is
48?
sorry,
Sir, is it 48?
48. No. How come 48?
Sir, I just worked out and so like I got 48.
Can you explain the process?
Yes, sir. So what I did was I wrote n square as 72 into some number p.
Okay, some number p. Okay, x n square equals 72 into p. Okay.
And then I just divided 72 into its prime factors.
Okay.
And just I kept on putting p for like which n was satisfying.
Sorry.
And I took the under root
Hmm.
and I just kept on giving values to p which satisfied like n.
You took the under root of what?
I took the root of n square, so it will be root of like the 72 into p.
So this will give us 2. This will give us 3. So 2 times 3 becomes 6. So n equals to 6 into under root p. Right?
Yes, sir.
So this would anyway be not possible.
So like it will be so it will be 2 cube into 3 square.
Right. So the thing is, it is given that n is a positive integer first thing. Okay, n is a positive integer. Second thing, it is given that n square is divisible. So if n is a positive integer, let's take it as 6. Okay. So n square becomes, or let's take any, not necessarily n. Let's take x as 6. X square becomes 36. So it has 2 into 2 into 3 into 3 as factors. So 2 2s and 2 3s. Okay. Yes, Ashwin, the answer will be 12. The reason being n square is 2 into 2 into 2 into 3 into 3 into x, or not, let's not take x, let's take p. Now this particular pair makes a perfect square, this particular pair makes a perfect square. for n square to be a perfect square. Now this is anyway a perfect square. How do we know that n square is a perfect square? Because, well, anyway, first of all, n, it is written that it is n square. And the other thing being, it is given that n is a positive integer. It is not given that n is a real number. Had it been a real number, then there will have been two possibilities, 6 and 12 both. But it is given that n is a positive integer. So if n is a positive integer, then n square will be a perfect square. Does that make sense to everyone? Or is there anyone who has not understood? Anyone who has not understood can ask the question.
Can you repeat that, sir?
What particular part?
The last line. I'm actually missed it. The n and the number part.
Okay. So if, let's say, if we would have taken n is equals to 2 root 3. Now this here is a real number. This is not an integer, right? Because there is a rational part to it and there is an irrational part to it. So this comes under real number. This does not come only under integer. Okay. Now, so n square becomes 2 into 2 into root 3 into root 3 or 4 into 3 or 12. Now 12 is not a perfect square, right? Does that make sense?
Yes.
Just a second, Venkatesh. I will get back to you about it. Okay, so here it is given that n is a positive integer. So if n is a positive integer, then n square has to be a perfect square. Okay, it cannot be a number which is not a perfect square. So therefore, if n square is divisible by 72, we can basically write it as 72 times p. P can be any other, all the product of the factors that are there in n square. So this is 2 into 2 into 2 and then 3 into 3. Now given that n is a perfect square, this and this pair, these two pair makes it a perfect square. However, this particular pair is incomplete. So it has to be, it is compulsory that p will have another 2 as its factor there. Otherwise, n square will not be a perfect square, but which we know. We already know that n square is a perfect square. Therefore, what we can say is n square we can also write it as 144 into q, where q into 2 is basically p. Okay, we have taken 1, 2 from here and put it with this. This is what we have done. Now, if n square is 144 into q, then n will become 12 into under root q. Does this make sense to everyone? Anyone who has not understood yet? Okay, so 12 will be the answer.
But
that-
Q can have any value, right? Q can have.
Q can also have, Q's will also have prime factors in pair, because only then will n square be a perfect square.
Noted. But let's say sir, Q is 4 or 9, right? Then n becomes 24, 36, or if it's 16, that would be 48, right? How is the largest number 12?
Sorry, I didn't get the last part. Can you
Okay,
please-
so if Q, let's say the value of Q is 4,
Right, right.
the answer would become 24. If the value
Right.
of Q is 9, it will become 36. If
So
it's
if-
16, it become E. So how is the largest positive integer as the answer is N over
It
here?
can also be 5, it can also be, I mean, it can also be 25, it can also be 121. We do not have to worry about the possibility here. What we ever have to worry about is what we can conclusively infer. We can conclusively, this is like basic, basic flow of reasoning here, that since n is a positive integer, then n square will be a perfect square first thing. This is a reasonable relation that you can draw between n and n square. Okay. Now,
Then shouldn't the answer be the smallest positive integer, because that's what we are doing. We are adding minimum value to P.
no.
make-
Then the smallest possible value, smallest positive integer will be 6, then it will not be 12. Because n will be divisible by 6, it will also be divisible by 12. Here, when it is asking the largest positive integer, it is basically asking from this given particular value. Okay, because had it been 24, okay, let's take it as 24. 24 is basically what? 2 cube into 3, right? Then it should have had sorry, n square should also have been divisible by let's say what, 2 3 4 432. N square should have also been divisible by 432, and it is not given to us whether n square is divisible by 432 or not. Does that make sense?
Sir, it is also not given that 72 is the largest number by which n square is.
Yeah, exactly. So according to this particular given information, whatever is given, according to that, what is the largest part? The question, whenever like it is asking, it is, I mean, sure, obviously then it can also be divisible by 36, it can also be divisible by 48, but it depends that what all factors does n square have. If we do not even know what all factors n square has, we cannot conclusively say no. For these two numbers, we can conclusively say without knowing the other factors. That is the thing.
But again, we are assuming that n square is equal to 2 cube into 3 square into p, where p is 2. So there again, we are assuming, right?
How we are assuming? How? N
It has to
square.
be, it can be 2 into q, where q is again a perfect square. P, I'm talking about p here.
Yeah, okay. So 2 into 2 into 2 into 3 into 3, and then I was saying p, right?
Yeah,
So p, it has to have another 2 in it.
yeah, I agree.
Yeah, to make it a perfect square. This is there. Now, whatever other factors are there, this can be 5 into 5, this can be 11 into 11, this can be 7 into 7, it can even be 2 into 2. But can we say for sure that it is 2 into 2, or can we say for sure that this is 5 into 5? This we can say for sure that it will have another factor of 2. This particular thing we can say for sure. Why? Because this is a perfect square and it has to have another factor of 2 for n square to be the square of a positive integer. Does that make sense?
Yes, sir. But this largest is what is giving the confusion here.
So
we
largest
can
is given
think
by
the other
the
way.
given information. No, it is given that n square is divisible by 72. Had it been given n square is divisible by 72 or and by any other number as well, then all of these would have applied, not only 48, not only 36. By the
Fine.
given, sorry,
Okay, sir. Understood.
yeah. So by the given information, 12 will be, I mean, sure, 24, 36, 48 can be the possibility, but we cannot conclusively infer that. That is the thing. For this question, if W is a set of all integers between 49 and 99, inclusive, that are either multiples of 3 or of 2, or both, then W contains how many numbers? Okay. So for set W where integers are between 49 and 99 inclusive. So 49 is also included and 99 is also included. Then it says that there are either multiples of 3 or multiples of 2. So let's start with multiples of 2. The first multiple starting from 49 is 50. So this is the 25th multiple. The last multiple until 99 is 98, which is the 49th multiple. Okay, so this will be number of multiples of 2 will be 49 minus 25 plus 1, which will give us 25 multiples. Okay, similarly, number of multiples of 3. Okay, so number of multiples of 3. The first multiple of 3 starting from 49 would be 51, which would be 17th multiple of 3. Okay, and the last multiple would be 99 itself, which would be the 33rd multiple. So 33 minus 17. Yeah, 33 minus 17 becomes 16. Okay, 16 and then plus 1, 17 multiples into. So 17 multiples of 3 and 25 multiples of 2. Now the thing is, in this set, the multiples of 6 as well, because it is saying the multiples of both, right? So the multiples of 6 as well have also been included. So what we'll do is we'll first take out the number of multiples of 6. So 54 will be the first multiple starting from 49 and 96 will be the last multiple. Now 54 is the 9th multiple of 6, 96 is the 16th multiple of 6. So 16 minus 9 plus 1 gives us 8 multiples basically. So the number of multiples, the number of numbers that W contains would be 25 plus 17 and minus 8, which would be 25 plus 9 or 34. 34 multiples into. Anyone who has a problem?
So why did we add a 1 to each?
Okay, so the thing is, when we are subtracting here, what happens is we are not necessarily counting either one of the end points. Okay, so if you start counting numbers like basically so when we are subtracting the lower limit from upper limit, which is not a range, okay, like which is not a range. How? Let's say the range is time. So if let's say we are subtracting 1 hour from 10 hours, 1 hour only gets completed once it is spent. Okay, it is a range of something. It is not necessarily a quantity in its own. So if let's say we are counting the number of hours from 11 a.m. to 7 p.m. Okay, so what do we do is from 11, instead of 11 a.m., let's take it 1 p.m. to 7 p.m. Okay, so if we are counting the number of hours between this, time is a range. Okay, it gets counted only when it's completed. 1 p.m. in itself is not an hour. It is the time. It is the moment at that exact particular time. Okay. However, when we are counting quantities are numbers which can be quantified. Okay. Numbers can be counted on its own. They exist on its own. They do not need to deplete for them to be counted. Does that make sense? Who was it who asked the question? Excuse me, who was it that asked the question? Okay. Basically, to also write it out as, so if you say 50, 52, 54, 56, 58, 60, 62, 64, 66, 68, 70, 72, 74, 76, 78, 80, 82, 84, 86, 88, 90, 92, 94, 96, and 98. So these are the numbers that we are counting. Okay. When we subtract this particular number from this, or like this is the 25th one, and this is the 49th multiple. So when we subtract all these particular multiples, then only these get subtracted, these countings get subtracted, this particular one does not get counted. Does it make sense now? Okay, so that is why like this becomes 25 multiples for 2, for 3 it becomes I think 17 multiples if I'm not wrong, and then for 6 it becomes 8 multiples. So 25 plus 17 minus 8 gives us 34
But
multiples.
sir, but why we are subtracting that multiples of both?
Oh, first of all, you asked like why we're adding one, right?
Yeah, we are adding multiples of 3 and multiples of 2, but
No, no.
why? Yeah,
Continue. Sorry, complete the question.
yeah, we are adding both the multiples, and why we are
Your voice is
subtracting the multiples of 6?
6.
Yeah.
Okay. So the thing is, in the multiples of 2, when we are counting the multiples of 2, such as 50, 50, 52, 54, 56, and then 60. Okay, and then let's take, no, sorry, not 60, 58. So then 60, 62, 64, 66, and 68. So in all the multiples of 2, the multiples of 6 also get added. Similarly, 78 will also be counted, 72 will also be counted. Again, the multiples, when we are counting the multiples of 3, so 51, 54, 57, 60, then there is 63, 66, 69, and then 72. Again, when we are counting the multiples of 3, again the multiples of 6 also get counted twice. Does that make sense?
Yes, sir, got it.
So to reduce, like to remove the discrepancy, we
Yeah.
subtract the multiples of 6.
Okay.
Okay. This question: a contract hires 100 men to finish a job in 50 days. After 14 days, and men leave. After some more days, the contractor hires 2 and more men to complete the job on time. For how many days did these 2 and men work? This is a nice question. Please continue. Okay, Ashwin, would you like to help? Would you like to answer the question?
Sir, am I audible?
Yeah, you are audible.
So first, it's given like 100 men are employed to finish a job in 50 days, and then after 14 days, and then leave. So then for remaining 36 days, 2 men are employed. So 2n is equal to 36, n is 18.
Sorry. 100 men to finish a job in 50 days. Okay.
After 14 days means remaining 36 days are there. So 2n men are employed to finish the work in 36 days, and n will be 18.
36 days are left. Okay. So basically, and men leave. I am not even, I mean, the answer is correct, but could you explain your procedure again?
So actually, 2n men are employed to complete the job in 36 days.
Right.
So that means n will become 18. So 18 days is the answer.
You just divided to
Yeah.
2n equals 36.
36. Yeah, I did that.
Okay. So 100 men in 50 days. So 1 man in
% will be completed in a day.
Okay, yeah, 50 into 100. Okay, so this is this. If let's say 100 minus n. Okay, yes, great, makes sense. So answer is anyway. I told you earlier also. Answer is correct, but I just wanted to understand your procedure as well. So if n men like leave after 14 days, there are only 36 days left. Okay, so basically, what do we say that 36 is 72% of the work is left. So he hires 2 and more men to complete the job. So he's basically compensating the n men as well as n men more, right? So 2n will complete it in 36. So n will be 36 upon 2 or 18 men. Does it make sense to everyone, or is there anyone who has not understood? Okay. This question here, in a certain sequence, each term beyond the second term is equal to the average of the previous two terms. If A1 and A3 are positive integers, which of the following is not a positive value of 5? Okay. Vishal, would you like to help?
Yes, sir. So it's given that A1 and A3 are positive integers, and in
Right.
sequence, the next term is the average of the other two.
Right.
A3 is equal to A1 plus A2 by 2.
A1, A2, A3, A4, A5. A3, A1 plus A2 by 2. Great.
So if A3 is an integer, it is evident that A1 plus A2 is an even number.
How? Wait a second. Sorry.
If A3 is an integer, A1 plus A2 should be an even number.
Great. Very good. Yes.
So the case is either that both are even or both are odd.
Great. Makes sense.
So, and similarly, we find till A5. A5 is equal to A3 plus A4 by 2. And we substitute A1 and A2 for A3 and A4.
A5 is A4 plus A3 upon 2. Okay.
Yes. And as I remember, we substitute A1 and A2 for A3 and A4 from the first equation. A3 is equal to A1 plus A2 by 2. So
Right.
for A3, we substitute that, and then from that, we find A4 in terms of A1 and A2.
You
So
mean
we
to say that we substitute the value of A4 as A1 and A2 and A3 as A1 and A2?
Exactly.
Okay.
So we'll get it as 5A1 plus 3A2 by 2 or 3A1 plus 5A2 by 2. I'm not sure. So once we get that, we can group it as like 3A1 plus 3A2 plus 2A1.
Yeah, irrespective whether like even if it is 3A1 and 5A2 upon 2 or it is 3A2 and 5A1, it does not necessarily matter. Okay, what matters is that either like if this is even, this also has to be even. If this is odd, this also has to be odd. Irrespective, both of the sum of both of them will be even.
The denominator will be 8, sir, not 2. 3A1 plus 5. 3A1 plus
right,
5A2 by 8.
Right.
So when we compare options, only the D
Right.
option is satisfied
Great.
because 75 is an odd number. We should get an even number in numerator.
Right, great. No, the answer is correct. Okay. I'll also explain this with the help of another explanation. So A1, A2, that was actually brilliant working, to be honest. So 5 numbers A1 to A5, it is given that A1 and A3 are positive integers. Okay. So if both of them are integers, this becomes X, this becomes Y. Let's take it as X and Y. Okay. And it is given that the third number or this particular every number is the average of the previous two numbers. So A3 is basically A1 plus A2 over 2. Okay, now A1 we know as X, A3 we know as Y. So 2Y equals X plus A2 or 2Y minus X equals to A2. Okay, so this becomes what? 2Y minus X. Yeah, 2Y minus X. Right, now what we can do to take out the value of A4, we can write A3 plus A2 over 2. Now this becomes as what? This becomes as A3 is Y and A2 is 3Y minus X over 2 or 4Y minus X over 2, right? Anyone who has a problem till here? Okay. Wait a second. Right. Now for A5, it will be A4 plus A3 over 2. Now A4 is what? 4Y minus X over 2. And then we also have A3. A3 is Y. So this and then all of this over 2. So this becomes 4Y minus X plus 2Y all over 2, and this again all over 2. So this becomes 6Y minus X over 4. Does that make sense to everyone? Is there anyone who has not understood? Now, out of this here, the denominator is 4, and we know, since as Vishal put it, that both of these numbers are positive integers. If this is integer, then these two have to either be even, or both of them have to be odd, right? So if what we can do is we can just break 6y minus x as 2y minus x plus 4y. Okay, we know that if this is even, then this will also be even. Okay, so if this is even, this automatically becomes even. If this is odd, this automatically becomes odd. Irrespective, this particular sum will be even. Okay, so if this is even and this is upon 4, so this can be the answer, this can be the answer, this as well can be the answer. However, this particular thing cannot be the answer. The reason being, because then this would not give us, like here the denominator is 4. It cannot increase till 8. It can reduce to this. It can also reduce to this, but it cannot increase to this particular value. So D would be the answer. Does that make sense to everyone? Anyone was still not understood? Okay, then we'll wait for 2 minutes, then we'll start with the algebra, and we'll also try to kind of cover up and rush through at least the first 2 topics for today, which is going to be our lines and angles, and then it's going to be triangles. Okay, we're gonna take a 2-minute break and then we're gonna continue. Okay, so algebra. Sorry, I told you the topics for geometry instead of algebra. Okay, so algebra today, what we'll cover in algebra are first of all expressions. What are expressions in general? And then we'll cover, I think then there is like linear equations and everything. There are certain properties, rules. Yeah, we'll start with this only for today. We'll go with expressions and everything. And then there will be our equations, basically linear equations. Okay, then there is quadratic equations. Then you have your inequalities. Then you have functions and notations. And at the last, you would have word problems. These are the 6 topics that we'll cover altogether. Okay. So what we'll do is we'll start with expressions today and also try to complete all the questions itself. So in algebra, the first thing that you have to remember is first of all, algebra is nothing but posing of a question. Okay, posing of a question to reach to an answer. This is why we necessarily use algebra. Okay, that is basically it. Like, how does algebra help us? So, if let's say there is a particular unknown, okay, the algebra aspect, the algebraic aspect of mathematics is basically the amalgamation of unknown with the known. Okay, and the usage of it is basically to find the value of the unknown. So if let's say we say that a plus 5 is equal to 7, then the value of a is what? Is a equals 7 minus 5, which is 2. So we are basically finding out the value of the unknown, which comes from the help of algebra. Does that make sense to everyone? Okay, then the first thing that we study with will be expressions, algebraic expressions. Now, algebraic expressions is basically when when you know, a mathematical a particular statement. So let's say if I've said Tom bought 5 apples and 7 mangoes, and he paid 350 rupees in all total. So if let's say I do not know the value of apples, which is A, and I do not know the value of mangoes, which is B. So this here would be the price of apples, this here would be the price of mangoes, and then this is actually equal to 350. Now, if let's say I say collectively, 1 apple and 1 mango costs well, let's take 120 rupees. Then find out the you know, the value of 1 mango as well as 1 apple each. So this is how we use the values of the known values to find out the values of the unknown. Now, there are certain parts, there are certain what do we say, basics of an algebraic expression, which is constant, variable, algebraic expression, and then there is algebraic expression. Okay, so let's say if we have written x plus y plus z, or 3x 7y 19z 19z, okay, and plus 4, then this itself is a term. All these 4 values which are separated with the help of the addition sign are a term. Whenever two values are separated by any of the operators, they become a term. So 2a plus 3b, this is a term and this is a term. Okay, then 2a minus 3, then also this is a term and this is a term. However, when 2a times 3b comes into the picture, collectively they give 6ab, and this would be, I mean, this is also a term and this is also a term, but they give rise to one particular term in total. And however, when addition and subtraction are involved, this does not happen. Okay, before learning about this, we'll also talk about like and unlike terms. But before going there, let's talk about the basics of algebraic expressions. So let's say there is an expression as 3x 7y plus 19z plus 4. Now, all these four different different values are known as a term of the expression. They are separated by these operators, which are known as algebraic operators, not operation, operators. Okay. The value which is constant and does not change, which is basically the numerical value of the whole in the whole expression is known as the constant. The alphabetical part of the expressions are known as the variables. Why variables? Because the value of the variables keep on changing. Okay. Now, all this collectively make a algebraic expression. Okay, this is an expression. This is not an equation. This is an expression. When we include a comparative sign. Okay, now comparative signs can be, they can be equal to, they can be not equal to, they can be less than equal to, greater than equal to, or just less than or greater than. All these signs are comparative signs. When we are comparing two values and then we write a particular number here or any particular other value here, then this whole thing becomes either a equation or an inequation. Okay, and this is basically called an open statement. An open statement is something which can be solved. Okay, this, however, so like let's say I have written 3 plus 4 equals to 7. This is a statement. However, this is not an open statement. This cannot be solved. This is given. This is how it is. It cannot be done. There is nothing that you can do further in this particular statement. However, for these statements, you can solve them. You can change them depending upon the values of the variables. Okay. Now, when there is only one particular term in the expression, it is known as a monomial. When there are two different terms, it is known as the binomial. When there are three different terms, it is known as a trinomial. More than three terms, it is known as a polynomial. Okay, and the numerical part of a term, when we are only talking about the coefficient of, when we only talk about the coefficient of x9, xy, then the answer is 9. However, when we, let's say, we say coefficient of 6a square b in 18a cube b square c cube. Okay, so when we talk about the coefficient of this particular value in this, it is basically the term divided by this particular term. I mean, all the factors, all the remaining factors, when we take out these particular factors out of the term. Okay, so does it make sense? Does it make sense to everyone? Is there anyone who has not understood until now? Any question, anything, any doubt? Okay. Now, combining like terms and unlike terms. Like terms in an expression is basically when, let's say, you have 2a, 3b, 2a square, 19b, you have 18a square, or let's say you have 17z and then 27b. So, like terms are basically those terms where the variable part, okay, the variable, the factors, when the variable factors of the term are similar to the other. So if, let's say, we talk about 16a square bc and we talk about 9a square b square c, this has factors as 16 into a into b into c, and this has factors as 9 into a into b into b and into c. Now here, if you see, A occurs twice, here also A occurs twice. C occurs once and C occurs one here as well. However, B occurs only once in this particular term and B occurs twice in this particular term. Therefore, the variable factors of this term and this term are not similar, and these two will not be like terms. Okay. Addition and subtraction can only be carried out on like terms. So these cannot be added or subtracted. They can be multiplied, but they cannot be added or subtracted. However, let's say this is the term and this is the term. Okay. Now what happens is the power of A, the factors of A are A into A, the factors of this will be A into A into B into B into C. Similarly, A into B into B into C. Now these variable factors of both the terms are same. Therefore, you can actually take out the variable part, the variable factors as common, and then you can add the numerical part or the constant or the coefficient part of the values, and this then becomes 40a square b square c. Okay, anyone who has a problem till here, who has not understood, needs me to repeat something? Okay. Then we have certain examples here. See, if we're adding two expressions, we are taking the sum of two expressions. What we have basically done is 5y here and then 4y here, 8 here and then minus 5. This is a constant and this is a constant. Okay, so we have put the like terms together, and two constants are also like terms. These are basically integers being put together. Okay. So we solve this and this comes as 9y. We solve this, this comes as 3. Now since 3z does not have any other like term to it, this will be kept separate, or like it wouldn't change. It remains as it is. Now, if we are simplifying this particular expression, then there is this term and this term which are like terms. So this 15n square and 6n square will be put together. Then minus 10n plus 6n minus 3n would be together. Now constant, there is no other constant other than 5. So 5 will be written separately. So this becomes 9n square minus 7n and plus 5. This would be the answer. Okay. Now same thing with subtraction as well. The only thing is the signs of the terms of the expression which is being subtracted changes. Okay, this is basically the rule of algebra, that plus into plus integers, plus times plus is actually addition, plus sign and a negative sign is negative sign and a plus sign is again negative, and when negative sign is multiplied with the negative sign, it is positive. Okay, so that is basically it. You can actually solve this here. Now, there are properties involved. We'll wait here and ask, is there anyone who has still not understood needs any other explanation, needs to go through the topic once again. Anyone? Now, these are the properties, the commutative, associative, identities, inverses, and then there is also your distributive property. This is something that we have already studied when we studied integers. Okay, there was also another property which was closure property. But since we're not talking about integers here, since we are only talking about algebraic expressions, these are the properties that you have to remember. Okay, so if you add two expressions like this, the value would be the same. Multiplying a into b or b into a, it would be the same. Associative property, whether you add these two first or these two first, the answer remains the same. Whether you multiply these two first or these two first, the answer remains the same. Now, this is the identity of 0, or the additive identity of 0. This is the multiplicative identity of 1. A times 1 is always a, and 1 times any number is always the number itself. Okay, this is the additive inverse. And this is the multiplicative inverse property.
Excuse me, sir.
Yeah.
Sir, for identities in addition, won't it be a plus 0 equals to a?
Yeah, I think there has been a mistake. Right? Sorry, I think there was maybe a typing mistake or something. Okay. Anyone else is like, is there any other problem? Okay. Now next is multiplication. So 3 methods how we'll study about multiplications. First is obviously the most common is distributive. Actually, wait. The first that we'll study is FOIL method. The second is special special rules, and the third one, which is distributive, which is actually the most common. Okay, so distributive is, as you can see, 2 multiplied by any other expression is basically what we do is we do a multiplication over addition. So 2 times 3a square added by 2 times 8a plus 2 times 11. This gives us 6a square. This gives us 16a. This gives us 22. And this becomes the final expression. Now, the FOIL method is basically nothing. It is first what we do is multiply the first terms, then the outer terms, then the inner terms, and then the last terms. And then add all of these products. So if it is, let's say, a plus b times c plus d, this becomes first terms. So a times c. Then the outer terms, a times d. Then the inner terms, so b times c. And then the last term, so b times d. This is the product. However, the downside to this method is it only works with binomials. Okay, it doesn't work with any other method. Okay, the third kind is the special rules. Okay, basically your formulas. So one of the formula is obviously, as we have studied this earlier as well, it is basically a square minus b square equals a plus b and a minus b. So this is the product of 2 terms. So if, let's say, we have to multiply 73 times 67, this can be written as 70 plus 3, and this can be written as 70 minus 3. It becomes 70 square minus 3 square. Anyone who has a problem till here? Okay. So I'll give you certain formulas. If you do not know those formulas, kindly write them down. If you do, that is great. Okay. Right. So I'll give you around 10, 11 formulas. If you do not know the formulas, please make sure that you write them down. The first one is a plus b whole squared, which is a square plus 2ab plus b square. Second one is a minus b whole square, which is a square minus 2ab plus b square. Third one is a plus b and then a minus b, which is a square minus b square. Fourth one is a plus b whole squared added to a minus b whole squared, which becomes 2 into a square plus b square. Uh, a plus b whole squared minus a minus b whole squared gives us 4ab. What else? Right. So a plus b plus c whole squared becomes a square plus b square plus c square plus 2 times ab plus bc plus ca. Okay. And then what do we have? Then we have a plus root b whole squared. It becomes a square plus b plus 2a root b, and then we have root. I mean, you can interchange as well, depends upon you. Then we have a minus root b whole squared, which becomes a square plus b minus 2a root b. Okay. If you have written them down, I'll erase it. Now, then we also have a plus b whole cube, which is a cube plus b cube plus 3ab times a plus b. Now, this can also be written as a cube plus b cube plus 3a square b plus 3ab square. Now, then there is a minus b whole cube, which is a cube minus b cube minus 3ab times a minus b, which is a cube minus b cube minus 3a square b plus 3ab square. Yeah, then we have a cube plus b cube, which is a plus b times a square minus ab plus b square. Remember that when it is this, when a cube plus b cube is there, here it is a minus sign, and when it is a cube minus b cube, this becomes plus ab. Okay. That is most about it. They don't have any other formulas or any other special rules which will be specifically used. If there are, I would actually tell you when they come into the picture. Okay, so we'll try and solve certain questions for today. Have all of you written down these formulas? Whoever was writing, whoever wanted to write down these formulas, have you all done? Anyone who's still writing wants me to wait? Oh, great. We'll go forward. Okay, so we'll start with this question. This is a very easy and doable question within 30 seconds. We'll start here. You can write down the answer in the chat box. I started the 30-minute timer instead of 30-second timer. Right. Yeah, quantity A would be greater because this becomes A square minus 25. So no matter what value you take for A, this would always be greater. Next question, m plus 15, m plus n equals 15. Which one is greater? Yes, the answer is it cannot be determined since there are two unknowns in the expression. There are two unknowns. F can be minus 10 one time, n can be 14 one time, and can also be 15 one time. We do not know. And since we do not know what are the specific values of n, had it been like, let's say, it would have been given m is greater than 5, for example, maybe then we could have reached to a particular solution, right? But since it is not given in any sense, we cannot say for sure which quantity would be greater. So it cannot be determined. Okay, next question. Same concept. Let's go. Again, same thing. With since like if let's say the value of r is, since it is a positive integer, if r is 1, this becomes 1 upon 28. This is 7 by 4. This is smaller. If let's say r becomes what? If r becomes 4, then this particular fraction becomes 1 by 7. Again, this is smaller. If r becomes 7, then this particular fraction becomes 1 by 4. Still, it is smaller. However, okay, if I take the value of r as 28, now this particular fraction becomes 1 and this becomes 7 by 4, which is 1.75. It is still smaller. But however, if let's say I take the value of r as 56, now 56 over 4 over 7 becomes 56 over 28. So this becomes 2. There is a possibility, or there are multiple possibilities where r would actually be greater than b as well. So all those values will also yield where quantity A is actually greater than quantity B, right? There is also a possibility, like let's say if we take the value of r as 49, so 49 over 4 over 7 becomes 49 over 28, which is 7 upon 4. There is also a possibility that quantity A becomes quantity B. Since there are different variations of possibilities, only D will be the correct answer. Okay. Next question. The product of two negative numbers is 160 if the lesser of the two numbers is 4. Less than twice the greater. What is the greater number? This is a nice question. Let's go. Okay, anyone who has done the question? What is the greater number? I think yes. One is the product of two negative numbers is 160. So let's take one number as x, the other number becomes 160 upon x. The product of these two numbers, negative numbers, is 160, right? So one number is x, other is 160 upon x. Let's take this one as the larger number and this one as the smaller number. Okay. Now, if the lesser of the two numbers, so lesser of the two numbers is 4 less. So this is less than the greater by 4. So that means if we like by 4, right? Then it says then twice the greater. So if we say twice the greater, then still this is still smaller by 4. So what we can do is 160 by 4 plus 4. 160 by x, not 4. I'm so sorry. Plus 4 equals 2x, right? If we add 4 to it and double the greater number, then it becomes equal. So 160 plus 4x upon x equals 2x, or 160 plus 4x equals to 2x square. We can divide this whole equation by 2. This becomes 80 plus 2x equals x square, or x square minus 2x minus 80 equals 0. The factors of this, so that the factors of 2, right? Yeah.
Minus
The
10
factors of,
plus 8.
sorry?
Minus 10x plus 8x.
Minus 10x plus 8x. The factors of 80 such that the product is 80 and the sum minus 80 and the sum is minus 2. So as I think Vishal, right?
Yes.
Right. X square minus 10x plus 8x minus 80 equals 0. So x common x minus 10 and then plus 8 common x minus 10 equals 0. So x minus 10 equals 0, or x plus 8 equals 0, where x can be 10 and x can be minus 8. Now the thing is, it is given that the numbers are negative numbers, so this cannot be possible. So 8 is one of the numbers. Now the question is asking what is the greater number. We chose x as the larger number and the value of x is minus 8. Therefore, well, the answer is minus 8. Okay. Anyone who still not understood needs any sort of clarification? Okay. We'll attempt this question and then we'll stop here. Okay, we'll attempt this question for today and then we'll stop for the result. Yes, Pratisha. Pratisha, would you like to help?
Yes, sir. So, so on expanding p plus 2 whole square, it comes to p square plus 4p plus 4. And on the other side, we can expand it to p square plus 25 minus 10p. And p square gets cancelled. So we can solve the equation. 14p's.
Great. Wonderful. Also, another thing is, this is correct. This is usually the way to go for it. Another thing what you can do is, you can see is, see, these three will anyway go out of the picture. Why? because if you put -2 here and -2 here, values will not be equal. Similarly, if you put 5 here and 5 here, then also the values will not be equal. So for all of this, the values will not be equal. Why? Because like even if let's say one of these values is equal and the other is not, then also the option will not apply, right? So all these three values goes out of the picture straight away. Why? Because the brackets are different. Okay, so these three values are out of the picture right away. Now the only ones remaining are this. You can also hit and try. This is becomes 3.5. This all becomes -3.5. If we apply this particular value. Okay, so if we do that, like since it is squared, both of the answers would be the same, which would be 12.25 on both sides. So this is how you can also get the answer. Okay, we'll stop here today. Okay, we have more questions to go with. We'll actually attempt these questions tomorrow in the next turn. And then we'll also start with quadratic equations as well. Okay, hopefully we'll also complete quadratic equations, inequalities in the next turn itself, and probably by the end of next week we'll complete, I mean Saturday and Friday both together, we'll complete algebra. Like next week we'll complete algebra altogether. Okay, let me see the timeline that was decided for algebra. 252, right?
Yes, sir.
Yeah. Today is, yeah, we are actually ahead of our schedule, so not an issue. So yeah, next turn we'll complete algebra. I mean, not will complete. First of all, we'll complete this thing, the expressions. Then we'll complete quadratic equations. Will also complete inequalities, and hopefully, if possible, we'll also complete functions. Okay. All